Let us look at the next section, students. This section contains 10 questions. Each question has 4 options, out of which one or more than one option may be correct. So let's start with the next question. Let us look at question number 29. The mentioned reaction 2NO plus 2H2 giving us N2 plus 2H2O follows the following mechanism, which has 3 elementary steps. So the 3 steps have been given to us. So the examiner seems to be interested in the order of the reaction with respect to NO and H2. So if we look at the steps which are given to us, the second step is slow. It means that the second step is the RDS. And if we talk about the rate will be given by some constant K into concentration of N2O2 into concentration of H2. Okay. Now N2O2 is formed as an intermediate, so it cannot appear in the rate law. So we have to substitute N2O2 in terms of the reactants. So we have to use the first step which is given to us. So from the first step we can see that the K equilibrium can be written as concentration of N2O2 upon the concentration of NO whole square. So the concentration of N2O2 can be written as some constant K equilibrium into concentration of NO whole square, and we can substitute this value into the rate law which we had determined above. So the rate can be written as K times K equilibrium times concentration of NO whole square into concentration of H2. So the rate is proportional to NO whole square and the concentration of H2. So we can clearly see that the order with respect to NO is equal to 2 and the order with respect to H2 is equal to 1. So if you look at the options which are given to us, option A says that the overall order of the above mentioned reaction is 3. This is correct, students. If you look at the second statement, if the concentration of NO is increased 2 times, then the rate of the reaction becomes 4 times. This is also correct. The reaction is second order with respect to NO. If you look at the C statement now, if the concentration of H2 is increased 4 times, the rate of reaction becomes 4 times. This is also correct. The order with respect to H2 is 1. And if you look at the D statement, the order of reaction with respect to NO is 1 and with respect to H2 is 2. This statement is incorrect, students. So for this question, we have to select the correct statements and we have to mark the correct answer as option A, option B and option C. Let us look at the next question. Question number 30. A 6 gram mixture of H2SO4, H2C2O4 and some inert impurity is dissolved in water to make a 1 liter solution. 15 ml of this solution required 6 ml of 0.09 molar KOH solution for complete neutralization. 100 ml of the same solution required 4 ml of 0.03 molar KMnO4 for complete oxidation. So we have to comment on the percentage by weight of the 3 species given to us in the mixture. So let us assume that we have A moles of H2SO4 dissolved in 1 liter and we have B moles of H2C2O4 dissolved in 1 liter. So the concentration comes out to be equal to A molar, whereas the concentration of H2C2O4 comes out to be equal to B molar. Now if we talk about the reactions which are given to us, the first reaction is with KOH. So students, both of these can behave as acids and they will both be neutralized by the KOH solution. So the molarity is known to us. We can have 15 ml into the molarity of H2SO4, which is A, into its N factor, which is 2. Plus we can have 15 ml of the solution into molarity of H2C2O4, which is B, into the N factor, which is also again equal to 2. And this is equal to 6 into 0.09. So we have 30 A plus B equal to 0.54. So we have A plus B equal to 0.018. Now if you use the second information which is given to us, we have reaction with KMnO4. So out of H2C2O4 and H2SO4, it will be only the oxalic acid which will get oxidized. So we have 100 ml of the solution into the molarity, which is equal to B, into the N factor. N factor is equal to 2. So this is equal to the MEQ of KMnO4. So we have 4 ml into 0.03 molar into the N factor, which is equal to 5. So in solving this expression for the value of B, we have B equal to 0.003. So we have 3 millimolar solution of H2C2O4 and we have the value of A equal to 0.015. So we can now have the masses. So these many moles were added in 1 liter solution. So the mass of H2SO4 will be equal to 0.015 into 98. So this will give us a value equal to 1.47 grams. And if we talk about the mass of H2C2O4, we have 0.003 moles into the mass, which is equal to 90. So this is equal to 0.27 grams. So if we talk about the inert impurity, the inert impurity is going to weigh 4.26 grams. So if we talk about the options which are given to us, the first option, it says that the percentage by weight of H2C2O4 in the mixture is 9%. So 0.27 divided by 6 into 100 is going to give us 4.5%. So the percentage by weight of H2C2O4 is 4.5%. If you look at the second option, the percentage by weight of H2SO4 in the mixture is 24.5. So we have to divide 1.47 divided by 6 into 100. So this will give us a value of 24.5%. So the second statement is correct. The first statement was incorrect. If you look at the C statement now, percentage by weight in the mixture follows the order impurity greater than H2SO4 greater than H2C2O4. We can clearly see that this statement is also correct, as the mass of inert impurity is the greatest. So the percentage by weight in the mixture will also be greatest. And if we talk about the D option, the D option is also again incorrect, students. The percentage by weight, as we had seen before, it came out to be equal to 4.5% and not 6%. Students, for this question, we have to select the correct statements and we have to mark option B and option C as the correct answer to question number 30. Let us look at the next question now. Question number 31. Identify the correct statements among the following. So option A, it says, in the first transition series, beyond manganese, no metal has a trihalide except FeX3 and CuX3. This statement is correct, students. Nickel, copper and zinc, they do not form the trihalides. If you look at the second statement now, nickel is confirmed by adding DMG giving bright yellow precipitate. This is incorrect, students. Ni2 plus with DMG gives us a red precipitate. If you look at the C statement now, zinc and cadmium are hard in nature. This is incorrect, students. Zinc and cadmium are soft in nature. If you look at the D statement now, in the salt analysis in group 2, PBS is precipitated as black precipitate. So this is also correct, students. So for this question, we have to select the correct options and we have to mark option A and option D. Let us look at question number 32 now. An azeotrope is a mixture of two liquids which have same composition in the liquid as well as in the vapor state. There are two types of azeotropes, viz. The maximum boiling and the minimum boiling. A few examples of azeotropes with their azeotropic compositions are given below. So the azeotropes are represented by AZ. So we have been given two examples of minimum boiling azeotrope. So we have AZ1 and AZ2. The compositions and the boiling points of the respective components are given to us. And for the second set of examples, we have examples of maximum boiling azeotrope. Again, the azeotropic composition and the respective boiling points of the individual components is also given to us. So we have to comment on the statements which are incorrect. Option A. The boiling point of AZ1 is very close to the boiling point of ethanol, but less than that of ethanol. So if you look at azeotrope 1, so azeotrope 1 consists of H2O and ethanol, and the azeotropic composition contains 95% of ethanol. Students, if we talk about the minimum boiling azeotrope, the minimum boiling azeotrope will have a boiling point which is lesser than both components. So the boiling point of minimum boiling is lesser than both components. Whereas if we talk about the maximum boiling azeotrope, for the maximum boiling azeotrope, the boiling point will be greater than both components. So if we look at the first option, we can clearly see that the first statement is correct because the boiling point will be close to ethanol as the composition contains 95% of ethanol, but the boiling point is going to be lesser than that of ethanol. So the first statement is correct. If you look at the second statement now, the boiling point of azeotrope 2 will be lesser than that of water, but it will be greater than that of propanol. This is incorrect, students. the minimum boiling azeotrope has a boiling point which is lesser than both the components. So it will be lesser than both water as well as that of propanol. If you look at the third statement, the boiling point of azeotrope 3 will be lesser than that of water but will be greater than that of HCl. This is also incorrect, students. The maximum boiling azeotrope has a boiling point which is greater than both the components. So the C statement is also incorrect. If you look at the statement D now, boiling point of azeotrope 4 will be greater than that of both water and nitric acid. This statement is correct, students. So students, for this question we have to select the incorrect statements and we have to mark the answer as option B and option C. Let us look at the next question now. Question number 33. Three isomers of a coordination compound Cr H2O6Cl3 are A, B and C. Dehydration over H2SO4 have no effect on A. So concentrated H2SO4 does not have any effect on A. It means that all the water molecules in the complex are coordinated with the chromium. So the complex A can be represented as this. Now if we talk about the complexes B and C, it is mentioned to us that B and C are affected. So in B and C, not all the water molecules are coordinated to the central metal ion. It is further given to us that 0.1 molar aqueous solution of B show more elevation in boiling point than 0.1 molar aqueous solution of C. It means that B produces more number of ions in the solution. So we can confidently say that the complex B is going to have this formula, whereas the complex C is going to be this, with the water molecules being present as the water of hydration. So the compound B will contain one water molecule while this second compound will contain two water molecules. Okay. If you look at the options which are given to us now, the formula of A is CrH2O6Cl3. This is correct, students. If you talk about the second statement, C can show geometrical isomerism. This is also correct, students. There are two different type of ligands, MA4B2. So they can show cis and trans isomerism. So statement B is correct. If you look at statement C now, IUPAC name of B and C are different. This is also correct, students. They both have different representations. So they are going to have different IUPAC names for the complexes. And if we talk about the D statement now, freezing point of 0.1 molar aqueous solution of B is less than 0.1 molar aqueous solution of C. So this statement is also correct, students, as we had seen that B produces more number of ions. So the solution of B is going to have a greater depression in freezing point, and as such the freezing point is going to be lower. So students, all four of these statements are correct for this question, and we have to mark all of these as the correct answer to question number 33. Let us look at the next question now. Let us look at question number 34 now. An ionic compound ACl is simultaneously doped with 10 to the power minus 6 mole of QCl3 and 10 to the power minus 7 mole of RCl2 per mole of ACl. So if we talk about the doping which is happening in this question, students, QCl3 has Q3 positive. So for every Q3 positive which is added, there has to be 3 sites which has to be vacated by A plus, and out of these 3 sites, the Q3 plus will occupy only one site. So a total of 2 cationic vacancies created because of induction of one atom of Q3 plus or one ion of Q3 plus. If we talk about RCl2 now, similarly RCl2 has the dipositive ion, and for induction of one R2 plus, there has to be a loss of 2 A plus. So 2 sites will be vacant, and out of these 2 sites, one will be occupied by R2 plus. So this is going to create one cationic vacancy per ion of R2 plus incorporated into the crystal. Now if we talk about the actual number of moles given to us, we can see that the 2 into 10 to the power minus 6 cationic vacancies will be created by induction of 10 to the power minus 6 mole of QCl3, and 1 into 10 to the power minus 7 cationic vacancies will be created due to the induction of 10 to the power minus 7 mole of RCl2. Now if we talk about the concentration, we just have to multiply these numbers with Na and add them. So upon addition, we get 2.1 into 10 to the power minus 6 into Na. So if you look at the options which are given to us, we can clearly see that we have to mark the option B as the correct answer to question number 34. Let us look at the next question. Question number 35. Which of the following reaction has the correct given compound as the major product? If you look at the first reaction, PCC in presence of CH2Cl2. So the PCC in presence of CH2Cl2, it oxidizes 1 degree as well as 2 degree alcohols to the respective carbonyl compounds. So the first statement is correct. If you look at the second statement, we have the alcohol getting dehydrated with concentrated H2SO4. So this will lead to the generation of a carbocation at this position. And this carbocation will further undergo ring expansion to give us a 6-membered ring. This carbocation will further rearrange to form a tertiary carbocation, and then there will be a loss of proton to give us an alkene. So this is going to be formed as the major product. So the reaction given in option B is incorrect. If you look at the C statement now, the cyclohexanone is allowed to react with dilute NaOH. So this will create a carbon ion at the alpha position, and then it is allowed to react with CH3Cl. So the conjugate base will make an SN to attack, make this Cl leave, and this is going to lead to the formation of this compound. Now it is given to us that the product consists of only single optically active compound. This is incorrect, students. The attack of the carbon ion will lead to a formation of a racemic mixture and not a single isomer as mentioned to us in the question. So this is incorrect, students. There will be racemization which is happening. If you look at the D option now, in the D option we have 1,2-diketo compound. It is allowed to undergo. So the Wolff-Kishner reduction is going to reduce this double bond O and convert it into CH2. So the reaction given in option D is also correct. So if you look at the options, we have to select the correct option as option A and option D. Let us look at the next question now. Question number 36. Consider the flipping of axial to equatorial position groups in cyclohexane and other 6-membered heterocyclic compounds. So we have been given that Kf by Kb is more than 1, which means that this form has to be more stable. So this form is going to be more stable when there is intramolecular hydrogen bonding which is happening between OH and G. So we are looking for groups which can form hydrogen bonds with the H of the OH group. So if you look at the options, OCH3 can form a hydrogen bond, OH can also form a hydrogen bond, NH2 can also form a hydrogen bond, and F can also form a hydrogen bond. So students, for question number 36, we have to select all of these options as the correct answer. Let us look at the next question. Question number 37. Which of the following are not an example of associated colloid? So associated colloid are micelles, students. So we have to select those colloids which are not micelles. So if you look at the first option, protein plus water. So this is not an associated colloid. If you look at the second option, aqueous solution of sodium stearate with concentration of 10 to the power minus 4 molar. This is correct, students. It is an example of a soap and it forms a micelle after the critical micellar concentration. If we talk about rubber and benzene, this is also not an associated colloid. And if we talk about gold sol, the gold sol is also not an associated colloid. So for this question, we have to select the correct option as option A, C and D. Let us look at the next question. Question number 38. There are some sugars given below. Which of them are reducing in nature? So students, for reducing sugars, they have to have a hemiacetal linkage. So by hemiacetal linkage, we mean that there has to be this group which is present. So if you look at the options which are given to us, the first option does not have any hemiacetal linkage. So this is going to be non-reducing. If you look at the second option, we have a hemiacetal linkage present here. So this is going to be reducing. If you look at the C option now, we have a hemiacetal at this position again. This is also going to be reducing. And if you talk about the D option now, this also has a hemiacetal linkage at this position. So this is also going to be reducing. So if you look at the options, we have to mark option B, option C and option D as the correct answer to question number 38.